Well, hi, welcome back. Once again, we're looking at practice problem number 24. We've got our friend Sarah, who's flying from Geneva to London. In previous videos, we did part A and we did part B. I have this up here for so we can remember from part B, the probability of a direct flight and luggage arriving. We got that to be 0.792 in part B. So now we want to take a look at part C. So part C says, find the probability that Sarah's baggage arrives in London. Well, something like this is where tree diagrams are so incredibly helpful. So let's look at our tree diagram. Remember, what we want is we want the baggage arriving. Well, let's look at our tree diagram. How many places do you see baggage arriving? Well, there's two. Our baggage could arrive here, using this path, or our baggage could arrive down here. Now, did you catch the little word that I used? My dog's barking in the background. I don't know if you can hear her, but did you catch the little word that I used there? Our baggage could arrive by taking this path, or my baggage could arrive taking this path. Did you catch that magical little word? Hear me say, or, this, or this. So as soon as you say that, what that usually means is that there's different combinations that could happen. There's different ways that we can get to baggage arrives. There's different paths that we can take, and we've got to consider both of those paths. In this case, it's only two. It's possible to have a tree diagram that has more than two branches, in which case you might end up with even more ways. But we've got to consider each of those paths. So let's take a look here. Let me get some colors working here. I'm going to take blue and how about orange? Okay. So what I want is I want the probability that my baggage arrives. And you can't see what I just wrote. Sorry. The probability that my baggage arrives. So let's see how that can happen. One way that can happen, I want to get to this spot. So how can I get there? Well, I can take this path. Oh, you can't see that path, and that path. So I can take those two branches. Will get me to my baggage arrives. Well, let's see what what's going on there. What that means is I could have a direct flight and my baggage arrives. That is one thing that could happen. That is one way that my baggage could arrive, or Sarah's baggage, is Sarah could take a direct flight and her plane could arrive. Now, what's the other way that this could happen? Well, Sarah could take a non-direct flight, so down there, and her baggage arrives. So the other path that Sarah could take is Sarah could take a non-direct flight and her baggage still arrives. So the other thing that could happen, I'll write this down, we could have non-direct and baggage arrives. Okay? Now, one thing that I often like to do, I a lot of times like to do calculations. I'm going to do two things. I'm going to show the calculation on the tree diagram, and then I'll show it in my little words that I have written out here. So if I want to get to this branch, how do I get to this branch again? Or this leaf, if you will, if we're talking about a tree diagram. So I can have direct and baggage arrives. So this is going to be 0.8 and 0.99. Or I could have 0.2 and 0.95. So I could have 0.2 and 0.95. So sometimes some people find it helpful to actually annotate the tree diagram and make little notes. Okay, here's a path that I'm going to take. Let me write down the way that I get there, like right here on the tree diagram. Now, if you prefer the writing, the actual words that we've been using here, okay, so the direct flight, well, that's 0.8, so direct flight is 0.8, and means multiply, arrives, well, if I'm on a direct flight and then I arrive, this is where my 0.99 comes from. And then the other thing that I could have is I could have my non-direct flight, which is 0.2, and which is multiply. Risa! Enough! Sorry, my dog is barking at random things outside. And arrives, so if I have non-direct flight and baggage arrives, I get my 0.95. So either way you want to do this. If you want to do this writing down the words like this, if you want to annotate your tree diagram, either way of organizing works. Different people have different preferences. But here's the kick. Here's the catch. Notice I've got two different things on the end of my tree diagram. All right, so this means I can have this path or I can have this path. Now, what do I need to do when I have or? Remember, or means add. So if you have multiple paths that you use, you're going to add those paths together. And in my writing here, I'm going to write the little word or right here, and or means add. So this is what this is going to look like. I can have direct and baggage arrives, or non-direct and baggage arrives. The nice thing about using words like this, again, if you write out the words and you get the and the ors in there, that actually makes it pretty easy to translate that into math, because notice all I did was I said, okay, what's the probability of this? This is multiply. What's the probability of this? This is add. What's the probability of this? And means multiply. And so I just converted all that. So let's see here. If we do this, well, conveniently, if you look back, this is why I wrote this down, direct and arrives, we already found that in part B. So this is, again, IB is actually helping us out. They're having you do parts of the problem along the way. So you're actually going to save yourself some time if you remember that you already did this calculation. And this ends up being 0.792. Or, and then if you go 0.2 times 0.95, I got that to be 0.152. Double check me on that. If I made a mistake, please correct that on your own paper, but that's what I got. And so now I'm going to add both of those things together. And I'm going to end up with 0.944. So the probability that Sarah's luggage is going to arrive is 0.944. And that's taking into account whether she takes a direct flight or a non-direct flight. This is just the overall probability. So if Sarah's going to be traveling and she's like, what's the probability that my baggage is going to arrive? So like if she really needs something, like if she's got medicine or if she's got, I don't know, something maybe like her favorite clothing or her favorite jewelry or something, and she wants to know what's the probability she's going to actually get those bags, that is a 0.944 probability. It's really tempting to write that as 94.4%. Technically, that's not incorrect. You're not going to get marked off for that. But when we're talking about probabilities, we usually just leave it as 0.944. And there you go. There is number 24, helping Sarah out and figuring out probability of her baggage arriving on time. All right. Thanks for joining me, and feel free to come back and join me again for the next practice problem.